Greetings and welcome, friends, mathematicians, enemies, those in between. It says the formula for circumference can be found like this. Today we're talking about circumference and arc length, which I think I'll use the joke again, is not going to be measured in cubits. Classic. All right. The circumference of a circle is the distance around the circle. Consider a regular polygon inscribed in a circle. As the number of sides increases, the polygon approximates the circle. All right, so a square is not a great approximation of a circle. Octagon, a little better. Decagon, even better. Imagine the number of sides of this polygon approaches infinity. And now you're starting to understand circles, my friend. The diameter of any of these is actually the same. All those blue lengths here are identical. And it turns out that as the number of sides increases, the polygon approximates the circle, and the ratio of the perimeter, what's perimeter? The distance around the shape, all right? The ratio of the perimeter of the polygon to the diameter of the circle approaches this number, which is about 3.14159. Bless you. Someone's allergic to pi. That's the Greek letter pi. You guys are familiar with that one. And it turns out for all circles, because all circles are similar, that the ratio of the circumference c to diameter d is the same, and this ratio is pi. Pi has been approximated by many cultures over many generations, and we have gotten more and more accurate. We currently have millions of digits of pi. Does anyone know how many digits of pi you need to estimate or calculate the circumference of the known visible universe within the width of a single hydrogen atom? No. No. You only need 32 digits of pi. All right, ladies and gentlemen, 32 digits of pi is all you need to calculate the circumference of the visible universe to within the width of a hydrogen atom, being the smallest of the atoms. So the millions and trillions of digits of pi that we have right now, we don't really need them. Yeah, so you can just be like, hey, psh, I don't need more than 32 digits of pi. Right? That's what you'll say. Yeah, so you can make someone cry on pi day when they're memorizing digits of pi. Solving for c yields the formula for the circumference of a circle. Right? If I multiply both sides by d, I get circumference is equal to pi times diameter. And because the diameter is twice the radius, right? Diameter, here's the radius, here's the diametrius. You can also write the formula. I'm assuming diameter and diametrius are maybe related. I don't know. Greeks were known for their geometry. You can also write the formula as c equals pi times 2r, or 2 pi r. 2 pi r. R. So, core concept. You guys knew this from elementary school. Probably. The circumference of a circle is c equals pi times diameter, or 2 pi r. Hey, check this out, friend. Hey, look at this cool rectangle I've got. What? It's a rectangle? You could imagine the perimeter of the rectangle is like the circumference. What? And you would just add them all together, am I right? You can roll it. Yeah, multiple times. Like, you just gotta, like, start it rocking like a vending machine. Ouch! It just, like, ran away. Hey, look it. Is your refrigerator running? Robert. Paterno. Man, represent Robert. Shout out. All right, check this out. I did that have a... I don't think that had a button for that. This is just rectangles. Yeah. But, gentlemen, ladies, consider the following. I think I drag it by this. What if I was to roll a circle, the distance around the circle kind of is 12.57 in this case, when the circle had a diameter of 4. Now, guys, check this out. This is the diameter of the circle. All right? Shh, ladies, gentlemen. Shh. Watch this. If I take this diameter length and I want to figure out, so how many diameters is the circumference? Right? Watch this. Flop, flop, flop. It's like 3 and a little bit more. It's actually like 3.14159-ish diameters. It's pi diameters. There are pi diameters that would fit into the circumference of the circle. Also notice, roll it up. If I make this diameter into 2, can I do it? Oh dear. That's so sad. I'm not going to be able to do it. I did it! Guys, and it was on the internet. Who's the esports pro right here? I'm like the esports pro when it comes to GeoGebra and adjusting the diameter of circles. If the diameter is 2, what is the radius? 1, and the circumference is 6.28. It only rolls out as far as that lets me. If I make the diameter 1, 3.14. Bop, bop, bop. Bop, bop, bop. Bop, bop, bop. Let's see, can I flop? It won't let me flop the radius. That's too bad. Well, anyways, circumference is the distance around the circle. Thank you, whoever made these GeoGebra files. You know your face. Right there. I'm guessing that's you. Boya View. Oh, wow, I didn't know that. Well, anyways, so circumference, am I right? I'm right. So let's do some you know what, for sake of time. Let's just do part B of example 1 here. Okay. So circumference of a circle with a radius of 9, I would have c is equal to 2 pi times 9. Tell you what, I did it wrong. Right, and that's just going to be 18 pi. That's exact equals. If you want an approximation using your calculadora, you would have to use a squiggly equal sign, which I like to call squeakles. Now, check this out. If I wanted the radius of a circle when I know the circumference, that's weird. So c is equal to 2 pi r. Yeah, what's up? You could leave it in terms of pi. Your pre-calculus and calculus teachers will appreciate that. If it's a real-world problem, this is also, by the way, in centimeters, then you could get a decimal approximation for the rest of the world. Joshua, questions? All right. I don't mind. 26 is the circumference, so plug in a 2 pi-er. And if I want to solve for r, what would I do? I'd divide both sides by 2 pi. 2 pi. And I'm going to get r is exactly equal to, goes into 26, 13 over pi meters. Exact. And if I wanted a decimale approximation, I could round it. Pi is a number, my friends, and it's exact. It's exact. Let's see. Arc lengths. So Joshua discovered a means to find the arc length. An arc length is the portion of the circumference of the circle. You can use the measure of the arc in degrees to find its length in linear units. So arc length is talking about what is the distance from 2 points on a circle along the path of the circle. And the way I do arc length, you saw us earlier, not my internet friends, but you guys did, in the start thinking, kind of use, we found the fractional amount of the angle to the whole circle, and we then multiplied that by the circumference. But using a proportion is actually a way cooler way to do it, which is what I'd recommend right here, this right here. So it says the arc length, right, Isaiah? The arc length of AB divided by the circumference should equal the measure of the arc divided by 360. Right? Whatever fractional amount the angle measure is, theta maybe, compared to the full 360, that's the same fractional amount that this distance should be compared to the entire circumference. So let's do this. Example 2. It's gonna be great. Guys, it's good to be back. Teaching the geometry. What did I do all vacation long without teaching geometry? Geometria. So, all right, let's find the arc length of AB. So, 8 centimeters is the radius. What is, well, actually, let's just do this all together. So, arc length of AB. I don't have a good way, they don't give me any symbols for that, do they? Guys, we should come up with a symbol to represent the length. L of AB. So, like, angle, and then L of A, lab. A bubble letter L. I'll just call it arc length of AB. There we go. So the arc length of AB compared to the circumference. How could I find the circumference of this circle if I know the radius? 2 pi times 8 is going to equal 60 degrees over 360 degrees. Am I right? Am I right? I'm right. So let's solve for the arc length of AB. Let's cancel some stuff out, friends. Swipe. 6 goes into 6 once and into 36 6 times. So this is 1/6. And you guys could cross multiply, or no, actually, I'm just going to multiply both sides by 2 pi over 8. But cross multiplying is fine too. What the heck? I'll just do the cross multiplication. I know that's what you guys like there. So, man, I got to find a better way to write. I'm just going to tell you what. I'm doing that. I'm lazy. So 6 times the arc length of AB is going to be 2 pi 8 times 1, which is 16 pi. And then what would I do to solve for the arc length? What would I do to get rid of the 6? Friends? I like it. And let's see, 16 and 6 are both divisible by 2. 8 goes into 16 and 3. So it looks like 8 pi over 3, and that's measured in centimeters. All right. Oh, what? No, they didn't. This time they gave us the arc length, and I don't know the radius. What did they tell? Yeah, they want the circumference. That's craziness, guys. Okay, so the arc length is 4.19. So plug in what you know, solve for what you don't. I don't know the circumference. That's going to equal 40 over what number? 360. Yeah, got to get those creds. Let's cross multiplicado. Actually, let's cancel some stuff out first. Cancel out those zeros. 4 goes into itself once and into 36 9 times. My canceling, my reducing? Oh, sorry. Oh, like decimals? Oh, this is amazing. You got to get used to it now. All right, so those cancel out. Basically, 40 goes into 369 times. 40 goes into itself once and into 369 times is what I'm doing. I'm reducing the fraction, and then I cross multiply, and so I'm going to get C, the circumference, is equal to whatever 9 times 4.19 is, and C is going to equal, I'm going to cheat, it's 37.71. Bless you, indeed. All right. Okay, what distance is measured here? That's the radius. And I have an arc. So let's see. So the arc length over the circumference. How do I convert a radius into circumference? 2 times pi times the radius, 15.28. That's going to equal, they want the measure of arc RS. So they want the misses. And that measure I should compare to what number? 360. So yeah, so now it's just a matter of simplifying and solving. Yeah, you could just multiply both sides by 360 is the way I like to do it, because this is an enumerator. It's being divided by that. So to get it by itself, the inverse of division is multiplication. So multiply both sides by 360 is what I would do. Let's see. Let's try this. 2 goes into 2 once and into 44 22 times. I'm going to multiply both sides by 360 instead of cross multiplying here. It'll end up being simpler. Yeah, that's scary, isn't it? Let's see. So 360 times 22 in the top is 7920 divided by 15.28 pi is equal to the measure of arc RS. Now, if I want to find out what that is in a non-decimal fraction irrational number sort of way, I could actually multiply 15.28 by pi, get an approximation, and divide 7920 by it. And that would be a calculator problem. And this would be a squeakle sign. It's kind of ugly because it's got like a decimal in a fraction. Basically, my rule of thumb is if the original problem's got a decimal, then a decimal answer is good. But if not, then give me improper fraction at times. Unless it's a real-world problem, then we should do that. So let's see, 518. I got to divide by pi. And you guys know how to find pi on your calculators? Yeah, there's a pi button there, friends. I can't fit it. So that's the approximate angle measure there. Well, thanks for watching, internet friends. Bye-bye.